Hello everyone and welcome to the first lecture of operating system. The operating system is the most important course as far as computer science is concerned. This subject consists of mainly theory as well as problems. An OS or operating system is like the control center of your computer. It's a special program that keeps track of and manages all the physical parts of your computer, like the CPU, memory, and storage. That is what this first line means. An OS is a program that manages the computer hardware, and it provides a basis for application programming and acts as an intermediate between computer user and the computer hardware. An operating system is a system software that manages the computer hardware and allows the user to execute programs in a convenient and efficient manner. In short, the OS manages hardware and makes it easy for you to run programs efficiently. Computer system organization. This is the basics of computer system operation and basics of operating systems. A modern general purpose computer system consists of one or more CPUs and a number of device controllers connected through a common bus that provides access to shared memory. This line here is a common bus, and each device controller is in charge of a specific type of device. The CPU and the device controller can execute concurrently, competing for memory cycles. To ensure orderly access to the shared memory, a memory controller is provided whose function is to synchronize access to the memory. Computer system architecture. CA means design or construction of a computer. Some computer systems have single processor and others have multiprocessor. Based on it, computer systems are categorized as single processor systems, multiprocessor systems, and clustered systems. The single processor system contains only one processor, so only one process can be executed at a time. Most general purpose computers contain the single processor systems as they are commonly in use. One main CPU capable of executing general purpose instruction set along with the instructions from users. The CPU contains one single general purpose processor. Other special purpose processors are also present with perform device specific. For example, when we press a key on a keyboard, the keystroke has to be converted to ASCII code, that is the binary code, which is done by special purpose processor. The next type is multiprocessor system. A multiprocessing operating system is defined as a type of operating system that makes use of more than one CPU to improve performance, which means and they are also known as tightly coupled or parallel system. As the name itself suggests, it contains of multiple processors. The two or more processors will be in close communication sharing the system bus, memory and peripheral devices, that means input output devices. There are a lot of advantages of multiprocessing systems. They are increased throughput or performance, economy of scale, which is nothing but cost cutting, and increased reliability. Throughput in a multiprocessing system refers to the amount of work or tasks that the system can handle over a period of time. Increased throughput means the system can process more tasks or data quickly and efficiently. Economic scales, which means reducing costs by producing or handling more units of a product or service. In multiprocessing, this means that as you add more processors, the cost per unit of work goes down because the system can handle more tasks simultaneously. And third one is reliability. Reliability in a multiprocessing system means that if one processor fails, others can take over the work. This means the system more dependable and less likely to experience a downtime. And there are two types of multiprocessing system. There are symmetric multiprocessing system and asymmetric multiprocessing system. And it means in a symmetric multiprocessing system, all processors are equal and share the same memory and resources. Each processor can run any task or process independently, and they work together to handle multiple tasks efficiently. And the asymmetric multiprocessing system, the processors have different roles. One processor typically handles the main task and controls the system. Processors have different roles, and while other processors are used for specific tasks or functions, the main processor coordinates the works of others. The third type is clustered processing system. In this system, it is another type of multiprocessor system. The cluster system is composed of multiple individual systems that are connected together.